Strings are always put in quotes. Note that you can use double quotes or a single quote. You just have to be consistent for the same object. It doesn't matter. There are issues if you want to use a quote or quotes within a string, or single or double. And we'll talk about that later. So anyway, these are just some examples of strings. So GIS is a string. That's great as a string. And the number 2 being treated as a string as opposed to being treated as a number, because again, it's in quotes. So there's some strings. Okay, let's just look at now string indexing. So let's say you want to pull out some of the characters within a string. So there's a couple different ways that can be accomplished. So here I've created a longer string, Geog 350, GIS Science. And for now, what I want to do is just comment. I'm going to comment out these lines because I want to show you some examples first. So again, to comment out code, you can put a hashtag ahead of it, and then whenever you run the code, that's going to be ignored. So if I run this now, all I do is just create the variable x that holds this string. Okay, so let's look at, say, printing values. So let's say we just want to pull out the word geography from the string here. So this would be at position 1 through, so 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So if I wanted to just pull out geography, it's what initially makes the most sense to me is you would do print x, and then you can put the range of positions you want in brackets here using this like bracket notation. So that would be from position 1 to position, I forgot, 1, 2, 3, 4, 5, 6, 7, 8, 9. Position 9. So let's print that and see what happens. Oops, what did I do? Oh, I forgot to close this. There we go. Just as a quick note, this error, unexpected EFO while parsing. EFO means end of function. It's basically like the end of a line. So it's expecting to close that with a parenthesis, and I didn't. All right. So anyway, here this spits back geography instead. So why is that? Well, first off, Python indexes from 0 as opposed to indexing starting at 1. So the first number, or the first character, is actually at position 0 as opposed to position 1. So that would indicate we need to move this back. So we would do 0 through 8 then, as opposed to 0 through 9. So now if we run that, we end up with geograph. We don't get the y. And that's because with the indexing notation here, the last position is not included. So you have to go one past what you actually want. So we want to go to position 9 as opposed to position 8. So basically this is going to grab position 0 through 8, which are the first through the 9th characters in the string. And then we should get back geography. All right. So let's go ahead now and clear out to get rid of those comments and look at these results. Okay, so the first result was what I basically did. So that gives us back the first word. The second result here gives us back 350. So that starts at position, so 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So it starts at 10. And then, so 10, 11, 12, and then again you go one past what you want, so 13, so 10 through 13. Note that blank spaces are counted as characters too, so that should make sense. Okay, and then you can also index relative to the end. So the last one here, we're going from position -14 to -11, and this is where you start at -1 at the end and add and then subtract as you go back. So this would be -1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So -14 through -11. So remember, you would be one extra space. So this would be -14, -13, -12, and then -11. So anyway, that's how indexing works. So you can count from the end. You start at -1, subtract as you go back. The first index is the index 0, and the last index is not included. There are some other things you can do. Just let me show you a few other examples real quick. So let's just get rid of these. And we can do something like, if we did print x, if you did like 0, that just means from the index 0 onward. So that's just going to print the whole thing. If you did 0 through 1, 2, 3, 4, 5, 6, let's not start there. Let's start at 350. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So this would be 10 onward. Right. So the empty after the colon means from this index forward. You can also do it the opposite. So you could do something like 10. So this should give you back 0 through index 0 through 9, right? So you can have empty spaces there. Okay, let's talk a little bit now about concatenating strings. So here I've broken this up into components. So I've got geography, 350, a colon, GIS science. And then here I concatenate that into a new string, and that's what the plus sign is doing here. So it's just merging everything together. So again, when you're dealing with strings, it's not addition, it's just concatenation or merging strings together. Note also the inclusion here of these empty strings. So again, I don't want the words to run together. So let me print this. So I don't want the words to run together. I would like to have a space between them, so I have this empty space that I've added where an empty space is required. Note that the spaces between the additions here and the content doesn't matter. So if I got rid of all this space, you're still going to get the same result. I tend to use spaces just because I think it makes things more readable, right? Also, the length argument, what it does is returns the length of a string. And remember, that includes the spaces. So just real quick, let me show you. Say I had something like x is equal to a, and then a bunch of spaces, or 1, I guess, and then a. And then we're going to do print length of x. So 41 as opposed to 2, because again, all these spaces are counted as basically characters or indexes in the string. Okay, let me just show you a couple other quick examples with concatenation, because this is something people do a lot. So, you can concatenate strings together. I'm just going to do, let's see, what do we want to do? Well, let's use our regular, we'll just use this again. So I'm just going to copy these variables down into here. And again, if we want to create this string, I can just do print, and we could do x plus y plus z plus w. And that would just run everything together. Oops, what did I do wrong? Cannot concatenate strings. Okay, so what did that happen? Well, that happened because this value, 350, is an integer or not a string, right? Now I could make it a string by just putting quotes around it, and that would fix the issue. That's all ran together, but we'll talk about that in a minute. Or another option is whenever I want to use that in the concatenation down here, I can just simply wrap it in the string function, and then it'll convert it to a string during the print process, and then it works. Again, what I say, like I didn't want to call z as a variable, I could just replace that with a colon. So you don't have to assign, obviously, everything to a variable. You can use a mix of variables referencing strings and also just strings. So that would give the same result. Now, again, if I want spaces, then I can just include those. So we'll do x plus, and then we'll add a space. So it's just a space within your within quotes there. And then same thing here, we'd want a space after the colon, and that should do it. So then we have it everything spaced out. Again, the spaces between the arguments here, the strings and then the plus signs don't matter. So if we remove those, we get the same result. This just demonstrates some of methods that are commonly used with strings. So here I'm creating a longer string. It's the name of a course with the content area, the number, and then the course name. So we'll talk about methods throughout the course, but basically a method is like a function, which we'll talk about in the next section. So it does something, but it's designed to work with a specific class and then can be applied to instances of that class. So strings have some methods that can be applied to them. And see the syntax here is it's the object followed by period, then the method, and sometimes you can include arguments, but there are no required arguments for this. So this .upper method basically is a method applied to a string that converts it all to uppercase. And this is a method that converts it to lowercase. And then lastly, this one, what it does is this split method will return a list of all the elements of the string broken at specific characters. So here we broke it at where there was a space. So if we run that, you can see here again we get all the string in uppercase, the string all in lowercase, and then here we return a list with all the components of the string, and we split where there's an empty space. We can split at something else. So let's split where there's an E, for example. So everywhere there's an E, we got a split. And note that the E's were not included, so they got removed. But the spaces were included. So for example, there's a space there. Yeah. So anyway, that's an example of doing a split. Then there are other methods. So for example, there's like title is a method, and that will convert it to title case, as you can see here, which it already is in title case, so it actually didn't do anything. And here I'm just printing those, but obviously that result could be saved to a variable. So you could do something like y is equal to... Sorry, I'm just going to get rid of all this stuff for now. So we're just going to do y is equal to x dot upper, and then we'll just do print y. And then we're saving that to the variable y as opposed to just printing it. Okay, so there's some things you need to be familiar with or that can be a bit of an issue when you're working with strings. So what if, I'm just going to add another block of code up here, you have a string that includes quotes in it. So quotes have special meaning. They're used when you define a string. So what if your string has quotes? So for example, we'll just do something simple like, let's see, this is a, and then we'll put quote in quotes in a string. Alright, so now if I try to execute this, I get this invalid syntax error. And that's because when I open, I start the quote here, when it sees this first set of quotes, it thinks you're ending the string, and then it gets confused, right? So it doesn't know how to interpret this. So one workaround is that you could just use the other type of quote, so a single quote here, and it'll accept that. You could also do it the other way, so you could use a single quote to define the string, and then use a double quote within the string. So just as long as they're different. Another option, so let's say we wanted to keep the double quotes, is you can make use of an escape character. So here, if you prefix this with a /, oh, I'm sorry, the other way around, backslash, then this will cause Python to interpret the quote symbol there as just a simple string as opposed to its special meaning in the creation of a string, right? So that should return the same thing. So let me just print that. So we'll do print x. And then we get this is a quote, and it worked, right? So a couple special cases. So if you have quotes within a string, you can use the other type of quote, or you can use the / escape character ahead of each quote. This is also an issue when you're dealing with file paths. So if you're on a Windows computer, you use like the backslash is the default, right, for the file path separation. If you're on a Unix or Unix-like system like a Mac OS or a Linux distro or whatever, then you're going to use the other slash, right, the /. So if you're going to use the backslashes in like a Windows folder path, you can fix that by just using 2 backslashes or incorporating an escape character, or you could go through and switch it to a /. This /n, that's used to create a line break inside of a string. So if I go back to this, I could have put this as a quote, and then before A, I'll just do \n, and that'll split it into 2 lines. So that creates a line break. And there are lots of other use cases to deal with these special issues, but these are some of the most common ones, and you'll see other examples throughout.